Hi everybody, I'm Fabrizio Maccioni. I'm a technical marketing engineer in the switching team, and I'm focused on programmability automation. And I started working in this area 3 years ago. I started in the data center side with the Nexus devices, and now I move in the enterprise side with the Catalyst. But essentially, as Sejun mentioned before, the idea is the same, trying to bring programmability in the switching side with the Catalyst platforms. With the programmability, it's a very generic term, and there are so many different buzzwords that are around network programmability and automation. And just to define what we really mean by programmability automation, the main idea is that we'll try to automate the entire network life cycle from what sometimes is called day zero, like where you'll provision your device. Day one, when you try to configure and making all the full configuration of the device, you start to monitoring and troubleshooting the devices themselves. And we usually try to divide in all the features that are under the programmability umbrella in 4 different buckets: the device provisioning automation, the programmable interfaces, the scripting, both on-box and off-box, so running on external server, and the application hosting, where there are applications running on a device themselves. Okay? For every bucket, there are several features, and the idea in Cisco is trying to come up with a feature that can be either turnkey solutions, so solution provided by Cisco that can be installed and are ready to use, or provide the infrastructure that a customer can use to build their own tool chain. Okay? We are going to be mainly focused on the programmable interfaces today. Okay? Another very key ask that we keep receiving from our customer is consistency across the different operating systems, the different platforms in Cisco. And so far, we haven't done a great job in this case, to say the least. So customer today, they might end up having a situation like this one, where to manage their infrastructure using Nexus, Catalyst, or ASR devices, they might end up using either CLIs, netconf, or different flavor on NX API. What we are trying to do now is to drive consistency across many platforms and many operating systems. We are not going to do with all of them. The main focus is trying to drive consistency across ISXR, ISXE, and XOS. Okay? So we are trying to bring the same functionality, or as much as possible, consistency across these 3 operating systems. We ran a survey last year, and where we found out that as of today, almost 95% of our customers are still managing their devices manually, so mainly by CLI or maybe some sort of a script, but still based on CLIs. And CLIs are fine for humans because they're very easy. Network engineers love CLIs, very easy to reproduce. You don't need any special tool. You just SSH to your device, and you can configure and troubleshoot them. But when it comes to automation, it's really hard to use the CLIs. And the main reason is that you don't have a structured data. You don't have any kind of error handling. You don't have any transactional mechanism on the CLI. So we are trying to drive APIs instead. And we have been trying to drive APIs for a while now in Cisco. We started back in 2005 with the very first implementation of netconf, known as netconf 1.0. Then we started introducing the WISMA, which essentially was a CLI wrapper, but at least it was providing a structured output data that was easier to parse. Then we moved to 1PK, but none of these solutions really worked fine. Okay? And one of the reasons why they didn't work, they were specific to Catalyst, while customers were trying to use something that they could be leveraged across all of them, right? So we started investing more and more in the new version of netconf. It's known as 1.1, even though I usually prefer to refer them through the RFCs, but that's the name that is usually used with some of the customers. And most of the content in the current RFC has been driven by the TLF folks. It's a company that we acquired in 2014, so whatever you'll find, like 80% of the content that has been there in the RFC has been built by the TLF folks that are now part of Cisco. So an open programmable interface would look like something like this. You have all your features, the device features, and you build the data models on top of the feature themselves. And you can export all the feature using different protocols, netconf being one of them, but lately RESTconf and gRPC are becoming more and more popular, so that an external server can leverage any of those three protocols and communicate using data models instead of doing it through the standard CLI over SSH. And if you drill down on the data models, usually they are split in a configurational data model, so essentially what you are instructing the device to do, in operational model, which is more like the state, like counters or the interface status. And for both configuration and operational model, there are usually what have been called either open or native models. So the native models are specific for a given device and a given operating system, while the open models are defined in open standard bodies or in a consortium like OpenConfig or IETF. The main idea is that we can provide both, and we are providing both the native and the open models. But in terms, the open model are always actually, a subset of the native models. Reason being that in order to define the open models, you need to have different parties to agree upon what's the content and what's the structure of the open model. So usually it's a very slow process, even though lately, to be honest, the OpenConfig consortium has been working very actively and it's coming up with more and more open models. But in the end, the native models will be always a superset of the open ones. So the idea is to, whenever an open model is available, to map the open model with a native model. And for whatever models that are not available in the open world, draw back and fall back to the native ones. Okay? So again, the idea is to leverage the open models whenever they are available. Whenever they are not available, fall back to the native ones. Okay?
There's going to be native models forever, right? Realistically?
Yeah. Mm-hmm. Yeah, there will always be native models, even because there are some features that won't be available in the open world. There are some specific features that are specific to the operating system and to the Cisco device, so that we can even use the open models and augment them with a Cisco-specific one, but there will always be the native ones.
And how different would you say that's going to be from enterprise MIBs and SNMP? Are there any? It sounds like the same thing all over again.
No, it's totally different.
I agree with you. It is a completely different approach. And even from the scalability point of view, from the architecture point of view, it's completely different. It's more efficient. It's more scalable.
Well, yes, that's not what I'm getting at.
Ethan, the trick is that you can augment the standard model and you insert your attributes where they belong in the standard model. You don't have to build a separate tree like you had to build with the MIB.
That's what I'm getting at, yeah. Okay.
But you will always have the models. Even for the given model, like for the interface, today we already support IETF and the native models. It's up to you whether you want to leverage the open or the native one. We still provide both at the same time.
But for me, it's a question on the vendor-specific platform native model. How much is it in a percentage? So how much is covered by the open model?
Not much as of today. That's the point. That's why we need still to have the native models, to have a better coverage of the features.
Do you have the same native model on Nexus OS and Catalyst?
They are different. That's the point. The native are different. While on the Nexus side, they are called DME, and they are based on the same model that have been used for the ACI world, right? While in the Catalyst device, they are Yang models, so are built using the Yang language from day zero. Okay, but the native are different.
Even if I use netconf on Catalyst and on Nexus, I can't configure them the same way.
If you use the open model, you can.
Oh, the open model, yeah.
They are going to be the same. The open model will be the same. The native models will be different. Yes, they will be different. Okay. But the key benefits of using open and programmable interfaces are structured data that can be either XML or JSON, depending on the protocols that are using. Will be XML on netconf, and you have XML or JSON in RESTconf. Error handling, so you know whether the netconf operation has been successful or not, and you can act based upon the error handling. multiple configs. So in the same operation, you can have multiple configs up to the entire configuration of the device itself. And transactional, so either all the configuration in the operation are successful or none. So if there is only one that is not working fine, we roll back so that we don't leave the device in inconsistent state. That's key.
So if I send you 5 configuration commands like changing the whole access list and applying the access list to the interface, and one line in the access list is wrong, you'll roll back to the previous version of the access list.
We roll back everything that is in the netconf operation, even DNS or whatever was in the same operation. We roll back everything so that the customer will make sure what was wrong, they fix what was wrong, and they'll set another operation with everything that is fine.
Cool, finally.
Is that what you're getting at with the multiple configs again? I think I missed that point.
It's part of it, meaning that at the same operation you can have a different configuration, and even if only one of them fails, you roll back all of them.
So your point here is I can make multiple configuration operations in the one netconf call. Yeah.
Oh, does that mean that you actually added commit to netconf?
It's the same approach, even though in a netconf you have a data store. So essentially you are doing in a data store instead of the running config.
Implemented candidate data store. Oh, finally.
That's the point. It's based on the data store instead of the real running config. So we make sure everything is fine before committing to the running config.
So you finally got the candidate config.
We finally got it.
When is that shipping?
It's already shipping. In the 16.3 release, we released July last year, it's already there. We are not providing the entire feature set, so it was just a subset of the models of the feature, and over time we are building more and more models. But netconf and Yang, they're already shipping. And the other key, it's based on open and standard models. So open models like OpenConfig ITF, and in open protocols like netconf and RESTconf. Okay. Now I'll switch to the demo. So let's start with the demo, and what I'm going to show you guys is how a customer can leverage netconf to build their own toolchain. And I built a very small website that goes through the demo itself. And the first demo is an application where you can have leveraging the models, you can sync the configuration between 2 different devices. And I'm using, on the upper left side, it's an ASR. And on the upper right side, it's a Catalyst 3K. So we can show how you can do it even across different platforms, in this case, a routing platform and a switching platform. And the main idea, again, is having one of the devices that is the master and one or more devices that are slaves. And you can configure or sync part of the configuration between them. The script that is running here, it's a Python script running in a standard Linux server. And then what it's doing is downloading from a given list of devices, a list of models. It's going to download all the Yang models locally to the external server itself. And this is the list of models that we are pulling down. And this is the script. So essentially, we wrote a very small library that will download all the Yang models to the server, a list of devices, again, a Catalyst 3K and one ASR. And then here is where we are downloading, copying all the models based on the XML file that I've just shown you guys. And then for every feature, in this case, I'm going one by one. I'm going to show you only one of them. It's NTP. I'm syncing the configuration, and I can provide even a rollback functionality. So let me run the script. And meantime, as you can see, the NTP configuration on the 2 devices is different. So we are going to see in a minute that the configuration on the Catalyst 3K will be synced to the ASR. So it was 1011 before on the ASR. You can see the same on the other one. And as I mentioned before, you can even roll back in a very easy way. So using another library that we have written, very easy. So where you say restore the previous configuration. So our rollback functionality are very handy, especially for customer. Whenever they're not happy about what has been configured, you can very easily roll back. So if we check again, the NTP should be in a minute, it should be back. Okay? And on if you check on the terminal monitor on the lower side, netconf has been used in order to configure the device itself. Okay? The other use case is about the transactional behavior. As I mentioned before, transactional behavior is very key. It's allow customer to deploy the configuration in a very safe way so that you make sure that you don't leave the device in an inconsistent way. So what we are doing here, we are sending one netconf operation where there is a DNS configuration and an interface description. But on purpose, I've introduced an error, right? The error right here, where the interface name is wrong. So I'm sending this network operation to the device. It will fail. You can check in the logs what was the reason why it failed, and it will say that the RPC failed because one of the operation was not correct. One of the arguments was not correct. In this case, the interface name. And if we check the configuration of the name server, we'll see that it's not configured for the very same reason, because the second operation failed, so we roll back even the first one. Actually, we didn't even configure the first one, right? As we said before, it was just in the data store.
How does it know that this is a transaction? Is there a keyword in the script somewhere? Or?
No, it's just the behavior of the network netconf implementation. You have a different operations. I mean, it's one operation with the different configurations, and you make sure that all the configuration are fine before you really commit all the configuration in the running config. Essentially, it's based on the netconf data stores. It's like trying to do the configuration in an external data store, make sure that everything's fine before really configuring all of them. Okay, this is the key of the transactional behavior. Any questions so far?
So the actual error message is embedded inside the netconf response.
Yeah, it is. So, and if you check the logs, what you'll get is an RPC error saying that the device refused one or more commands because there was an inconsistent value, where in this case the inconsistent value was the interface name. So you'll know not only that it fails, but you also know why it fails and where it fails, because you have the line in the specific call where you know exactly what failed. And that's a huge improvement compared to the CLIs. The CLIs, it's really hard to understand, first of all, that it failed. And even if you find it out, it's really hard to understand what failed. So it's really hard to fix it. Okay? The second demo is about on-box Python. So we are introducing on-box Python, so a Python interpreter running on the device itself. So we'll be running not in the native operating system, but in a Linux container for isolation, so will be safer for the customer. And as you know, network administrators are very, they don't like the idea to have external software running on the device. So for that reason, we are keeping on the Linux container, so for network isolation. And
just a small question, which box will get the Python feature?
For sure, all the next generation platform will support Python. We are trying to level Python support even in the current shipping devices, but it's not committed yet. But that's the idea. All the next generation will support it for sure. The current one we are trying to see. There are.
So on which platforms can I get Python in a container today?
It's not shipping yet. That's what I'm saying. They are coming very soon. Yeah. And I'm 16.6. 16.6, and we are trying to have it in 16.5 as well. But again, it's not committed yet, so I don't want to promise anything. I'm not sure we'll get it. Yeah. No, it's coming soon.
If I can have a question as well, from a security or vulnerability management perspective, since there are often vulnerabilities which are found, how is this going to be addressed? Is it going to be like, are you getting that from a, let's say, a public repository, or is Cisco going to maintain that Python implementation or that container?
So the Python implementation itself, so the container and the Python libraries will be maintained by Cisco. And we'll make sure that everything is fine. We're using secure Linux. We are making extensive testing to make sure that from the security standpoint, everything is fine. We'll coming back to your point, we were supposed to ship it before, and we found some of the security vulnerabilities. So we said, hold on, just a second, make sure that everything is fine before we really release it. And to show you the Python demo, we are going to leverage the embedded event manager. That is a feature that has been there in the Catalyst for a very long time. Not many customers are using it. But essentially, whenever there is an event that can be an syslog, it can be an interface going up and down, you can trigger an action. The action that the new action that we are introducing now is running a Python script. So with a very small configuration on the device, you can say, for instance, if this interface state goes down, you can run this Python script. And the main idea is, let's suppose you have a very important interface like an uplink. You want to monitor the state so that whenever it goes down, you can see what's wrong and have the configuration change so that the interface will be up again.
And you can use the EM commands,
Configurations,
variables, and you substitute them as the command line arguments for the guest shall run command, and then you can pass arguments to the Python.
That's correct. That's correct. In this case, the Python script is a generic Python script to unshut one interface, and the interface that I'm using during this demo is the Loopback 55. So that's exactly what I'm doing. Okay. And the Python script that is running in the Linux container itself, you can run CLIs. In this case, what you are doing is just building the CLIs, going in the configuration, building going in the interface Loopback 55, because I given as an argument, I just unshut the interface. Okay, so if I go here and I manually shut the interface or just remove the loopback will go down, will trigger the Python script, and the Python script will have the loopback interface backup. Okay, and you can see in the lower side all the syslog messages explaining what's going on. Okay. The second use case is config backup on change. So every time the configuration is changed, either via CLIs or via netconf, you create a config file, you save it on the boot flash, and you export it in the TFTP server. Okay. Configuration, it's still using the EM as a trigger. In this case, whenever they'll see a syslog configured from, it could be from CLI or from netconf, run another Python script. And the Python script in this case, what it'll do, it's just create the configuration. The name will be based on the time in the ISO format, and that's something that you cannot do with the standard EM. So this is one of the benefits of having Python on the device. You can use standard Linux libraries to build even the name based on the time. You save it on the boot flash, and you copy it on the TFTP. So if we check locally on the device, here we are, flash, config record, you'll see that there is a configuration file that has been created on the device itself. And if we go on the TFTP server, there are the same files are copied in external TFT server.
I have one question regarding to, are there limitations how big the scripts can be? And are there limitations regarding to when a script is producing too much load? How do you cover that this is not infecting the...
Well, yeah, for the first question about how big can be the Python script, there are no limitation per se. The only limitation will be the space that we have allocated to the Linux container. That's the only limitation that you are going to have. And the second one, what was again, sorry?
The question was, how do you cover that not a script is producing too much load for...
Okay, yeah. So what we are saying, in this case, we are limiting the CPU usage of the Linux container to 1% of the CPU, so that you'll make sure that there are no impact on the native operating system. That was one of the key in the architecture team, to make sure that whatever you are running on the Linux container, it doesn't affect the native operating system.